Okay. No. All right. I think we're ready now. Yes? Yes. Okay, so I'm introducing Ben Doherty and Ishaan Varshney, and I'm going to read their bios, which they're very uncomfortable about. According to 23andMe, Ben is unlikely to be a deep sleeper and likely to be able to detect asparagus odour. He's currently leading the research efforts at BVN, where they are looking at how they can make buildings more like Hogwarts, complete with moving staircases and furniture. Failing that, he wants to make buildings that are just right, TM, all the time. Outside of that, Ben teaches the design computing course at UNSW, and in his spare time, Ben likes to explore the culinary delights that can be made with the humble centrifuge. There we go.
This is what happens when someone else writes your bio.
They're now blaming each other. It's fantastic. Ishaan. As a child, Ishaan developed an unhealthy obsession with rolling down steep roads on his tricycle. Since then, he's been looking to get adrenaline rushes in the world of Python, as his tricycle doesn't seem to fit him anymore. Having worked in predictive markets, financial systems, renewable energy, who are the banking nerds in the room? Yeah, good. And construction industries, he's interested in solving problems people have described as being strange and cute. Ishaan has a bachelor's in economics and computer science and a master's in artificial intelligence from UNSW. He also lectured the design computing course at UNSW this year. Welcome, gentlemen. And they are going to be talking about teaching Python to design students. Please make them welcome.
Thank you. That's really thrown me.
We weren't expecting to have those bios read, so we will spare you our introduction. So basically, I asked Ben what his tertiary qualifications are, and he just said 1 million years at university studying architecture. So Ben's coming from an architecture background, and I myself I come from a computer science background, and we work at BVN, as was mentioned, and we just want to share our thoughts on how teaching Python to design students went in the 2 years that Ben and I taught. So Ben taught in 2017 and I lectured the course in 2018.
Okay, the rough structure of the course is that there is a problem, which is we want to teach Python to design students. We're going to talk about how we approached it, and then we'll talk a little bit about how it went. We got some feedback from some of our old students a couple of years on to see if they thought it was actually useful or not, which was actually quite instructive. So,
Programming, so it's interesting in terms of programming is really good for design students, but it's unclear how you would approach that problem. And that's the reason why Ben designed the first year course that he taught.
So, I just sort of decided that I wanted to teach the course because I was seeing the students get to the end of this degree and be surprisingly unuseful. And I figured that teaching them Python at the beginning would have a much bigger multiplier effect. So if I could get them doing something good right at the front rather than at the end, they'd be able to use that all the way through. And so the big question we're trying to work out is, why is learning programming useful for design students? And it seems kind of obvious to us, and it probably seems obvious to you if you're already here. But with most traditional design areas, there's almost an active hostility towards doing computery stuff. It's not that they think it's irrelevant, they think that it sort of harms the outcomes. And that's probably true in a lot of situations where people don't have a good mastery over the skill set, but you're starting to see people coming through now who've got mastery of all the traditional skills and all of the sort of newer programming skills. And so one of the sort of famous quotes from my head of school when I was at uni was that someone was complaining to him that the students he was turning out weren't really very employable. He was like, look, I'm not going to do the terrible Scottish accent. Look, I'm not training them to work for you, I'm training them to be your boss, because they're going to graduate in the future rather than graduate in the now. They don't need to be employable as first years, they need to be useful as future people. Are you getting me to do this now?
So the unclear bit is exactly how you would teach to design students. Because most programming courses at university are targeted STEM students. So this is just the excerpt from the UNSW Computer Science Handbook, and it basically targets these fields. So as and generally STEM students are already used to a certain way of thinking, which design students aren't. So it's unclear how a design student is meant to get up to speed. And also STEM students have role models. For design students, there currently aren't any role models who do programming and are very successful. So that's the conflict, as in how do you come up with an approach for design students to learn programming, because they probably got into design to avoid all of that.
So I think one of the things that we share, and we talk a lot, and Aidan, who's sitting just there, has to suffer through us talking about extremely weird things, is that the world of programming gives you a sort of mechanism for exploring the world. And I think it's kind of well illustrated by this sort of work, the explorable explanations work, which is done by Nikki Case and Brett Victor and people like that. And they're using programming as a mechanism to understand complicated things in the world just by making them into intuition pumps. The one on the left is a really nice article that just has little interactive things that you can use to explore how different voting models work. And by the end of that, even though you haven't really put a lot of cognitive work in, you really understand how voting works. And that's something that we think that you can do to designers, is you can give them these tools to develop intuition pumps. And so this is we had a fairly robust discussion about this, but STEM people, especially if you get into optimization, that kind of thing, you have this idea of a design space. And you can explore it. It's got a sort of well-defined number of degrees of freedom or dimensions. And you can know what it means to explore a design space from an optimization point of view. Design, there's a big debate in the sort of design world about whether it's search or whether it's something else. But you can think of design as exploring a search space with an undefined or poorly defined number of degrees of freedom, and some sense that you're exploring it through intuition and experience. And one of the things that we want to be able to do, like I was saying, is add to that experience and that intuition, like accelerate it by adding data and simulation to it. And if you have those tools, you can move through these intuition-derived search spaces much more quickly and much more effectively. And then, I don't know, sort of terrible maths joke in the middle of the night. Hopefully it becomes a multiplier on your intuition rather than just something that you add on.
But it begs the question, Ben, would design students actually learn programming?
Good question. Well, I did. We got this picture, and then Ishaan sort of pointed out that Sebastian looks a little bit like he does, which leaves me as the other person, which wasn't intentional. But so you can think about these sort of three things. My brain process was Trident, Little Mermaid, excellent. You've got programming as a mental discipline, a sort of philosophical thing that allows you to explore the world. In design, there's a lot of geometry and a lot of geometry analysis, which is a lot easier to do through programming because you're doing repeated tasks very quickly millions of times. And then there's the data aspect to it, which is traditionally done by reading a lot, like thousands of pages of documents, and then pretending that you actually bothered to pay attention to it. So jump on this. There's some examples here. This is some work that Aidan did on tracking the urinal use in the men's bathroom in the office. And this is a little Markov model diagram of the sort of states of the various threes you can do. And this is something that the only empirical work done on this was done in 1974 by a man sitting in one of the cubicles with his eye up against the thing and writing it down in his notebook. And so since then, there's been massive amounts of work on mathematically modeling this. All of the building regulations are done on Q models, on state transition models, that kind of thing, but there's no empirical data to back it up. So as far as we can tell, this is the first time anyone's done that. It told us exactly what we were expecting, but that's a huge relief. We're also working on a way of measuring the temperature, sound, and light, and then some additional qualitative questionnaire work as well in the office, which gives us a sense that we can start saying that people have different types of comfort areas. People would rather be somewhere rather than somewhere else. And that's all going through a kind of sensor thing. But collecting all that data and analyzing that data, doing the sensing might be a sort of specialist job, but collecting and analyzing it will hopefully become a designer job, something that you want to be able to understand that data. This is the ANZ Stadium redevelopment from about 4 years ago. The whole roof on that was built in about a day. I think it was a very, very long day, but I sort of modeled it up in...
Yeah, by built, design, like in a
oh,
computer.
Yeah, sorry.
Yeah.
I was like personally stapling it. Yes,
Yeah.
sorry. Not even designed, just modeled in a way that we could analyze. But that would, in a traditional design model, it's like clicking a lot, would have taken someone a month or two. And then this next one is a really interesting one in that it was a bunch of designers doing what is essentially a sort of exploratory mathematics task, trying to fit the biggest rectangle they could onto a given 3D printer build plate. And it turns out there wasn't an obvious answer to how do you fit a big rectangle on a small rectangle. And so they built a little exploratory model of this in Grasshopper, which is a patch programming language that has little Python nodes in it, and played around with it until they could work out the biggest thing they could print on our new 3D printers. And then the last little thing is the thinking discipline. And we talk a lot using sort of computer science shortcuts for things, like the idea of this is a parallel task, this is a serial task, we can abstract this concept over here, we can make this a kind of modular thing, we can reuse it. And those concepts work very well. This is a tree of our projects that we're working on. And that, as a way of explaining things to people, actually ends up being very powerful.
So, given all these benefits and given Ben's sort of description on here are all the amazing things you can do by knowing a bit of programming in design, Ben tried to fill this gap and this need with the course Code 1161 at UNSW, which has been taught for 2 years. So it was designed by Ben in 2017 and lectured by him, and then Ben went overseas and I did it in 2018. So just to give you a brief idea of what that course looked like. So it was 6 weeks of Python basics, so to get people up and running in Python syntax. And then it was 3 weeks of sort of machine learning slash, you can call it sort of software development, the ability to just, pull a GitHub repository, install it, edit it. And also there's the capstone project was a data analysis project. So you get a large data set and you essentially tell a story and provide some insights that you found using that data.
Oh, so this was the sort of, I found out that there were 3 of them and they were all started to C, which makes a nice story. But there's a lot of the online programming courses teach you a lot about competency, like if this is how you type a loop without getting it wrong, that kind of thing. But one of the things that we wanted to do, and we'll touch on this again, is make it valuable going to university. So these kids are paying an enormous amount of money to be in a room with us. And so what can we teach them that they can't get from Code Academy or something like that? And we were trying to make that be the culture and the concept thing. So by pushing how do you do a Stack Overflow search, or what does it mean to use GitHub, or where do you get your data from, or what does this joke mean, we were hoping to give them a sense that they could not only do the programmings, but also talk to the rest of the people in that world.
And also, part of that is you generally assume a sort of baseline level of motivation for someone who is enrolled in a computer science program. And here we have to sort of generate that motivation exogenously, and we'll sort of touch on that a little bit later. So we just want to share sort of the lessons of what happened in those 2 years. So the things that worked well, that didn't work well. So the things that worked well.
Well, getting them to tell stories worked really well. This is a picture of me trying to explain hit testing in convex hulls, which ended up with a sort of furor of fan photographs from the students. There was a lot of peer support in the Slack channels. One of the things that we found a lot is that we tried Piazza in the second year, and I think we'll talk about that in a second, but there are multiple layers of communication in any of these things. And it's interesting to see how much conversation is happening in the public Slack channels where they're supposed to be helping each other, and then the percentage of Slack messages that are coming across in private messages where they're sledging each other and winding each other up and comparing their Overwatch scores. But this worked quite well because people could help each other out while we were having normal sleep cycles and that kind of thing. You'd see a lot of traffic overnight. So this is something that we really struggled with, this idea of generating motivation. Because, as Ishaan was saying, if you're a computer science student, you've really already signed up for it. You're doing your degree because you wanted to.
Yeah, and generally, it sort of changed a little bit, but when I went through the computer science course, the first year or 2 years, it was just very low-level programming. So it was welcome to C, and that was your first introduction to computer science. And then the next semester was welcome to C again, but this time we were doing algorithms. And it's definitely not the best approach for a design student who may just want to learn programming just to be able to do all the amazing things that Ben showed us.
So I can't remember why I put this slide in. This is, oh, right. So one of the things that people get a lot is when you're learning Intro to C, for instance, you get an error message. You've only done a very small number of things, so there's only a small number of things that could happen, could go wrong. One of the things we've really done is kind of thrown these guys right in the deep end. There's a lot of things that could go wrong. So we've really tried to do a lot of things to keep them motivated. So if they did something that was sort of obviously wrong, they'd get an error message and then have to discuss it, that kind of thing. But then, I do this. Okay, we added in a bunch of stuff. Like if they got an error message in a particular place, they got the grumpy cat nope. And so they'd have these little challenges that they had to write the code for the challenge, and then the tests would run against it and mark them, which meant they could mark themselves and keep going until they were happy with it, and then they'd submit it. The other things these were sort of me being thoroughly bored of writing the code for these tests. And when you get to the end of a programming exercise, if you get it all right, you get the cat. And I thought this was just going to be a kind of thing that people skipped over. But as this, I think this was week 2's exercise, started running through, these students were all amazed. They were all like posting it to Slack. Like the people there was like collecting pogs or whatever. I don't know if they had them in Australia. And that really motivated people to do stuff. So with loads of screenshots like that. So someone would get to the end of their like very basic binary search thing. These people have never done any kind of maths at all. They had set up a Linux virtual machine. They'd programmed a proper algorithm in Python, and then they'd got a like exciting cat in their terminal. And they were feeling pretty excited at this point. The other thing we did was, as we were saying about the active sort of discouragement that some of the mid-level design type people will give to people who want to get into programming, is we got quite a lot of senior people to come in and give talks about how the skills they were learning were useful and were going to be, they were important now, but were going to be more important when they graduated. So
this was a significant part of sort of our headspace when we were thinking about the courses. How do you abstract away some of the boring bits, or rather some of the unnecessary bits of development environments, yet get them just enough of an abstraction that they understand and have the ability to set things up themselves? So we have broken it up by year. So when Ben taught it, we used virtual machines in VirtualBox to essentially set up their dev environment. So the idea was they would install that virtual machine, and there were scripts on that machine that would essentially do all of the installation of libraries and
that was the theory.
Things like that. So that was the theory. And what we found is once you do that 50 times, there's a myriad of issues that crop up. Some of them have to do with going to the BIOS and enabling the hypervisor to be able to run VirtualBox. So so in 2018, we decided to move away from virtual machines and use Anaconda. And that worked really well because it's cross-platform. So all you have to do is just download Anaconda, and you can install your versions of Python from there. And you can also install different libraries. So there's some libraries that require C, sort of C underlying libraries, and you can do that quite easily using Anaconda. So we also used Atom in 2017. And how do you think Atom went, Ben, in 2017?
Fine.
Yeah, it was fine. It didn't get in the way. But we decided to go with Visual Studio Code in 2018 because when you have Visual Studio Code combined with the Python extension, it's really powerful, especially with that debugger. It allowed sort of a more visual view to code because you could see all the variables using Visual Studio Code. So that was quite nice. And in 2017, we used the command line to run the Python interpreter in Git. We decided to just try using desktop versions of them both. So we tried to remove the Python interpreter wherever possible using VS Code, and we used GitHub Desktop. And I think GitHub Desktop just it works well most of the time, except for the edge cases when things break, and you have to go. Yeah, you have to go to the command line. And we also used Jupyter Notebooks in 2017. Then we moved to Kaggle, and similarly, Kaggle breaks sometimes, and the students sort of start panicking because there's no other option. So probably Jupyter Notebooks are a safer bet. And this is just sort of, I just talked to that. So
one of the exercises was this thing called Holy Wars, which was, we tried to get the students to explain why you would choose Vim over Emacs, or whether you should have blue or red switches in your keyboard. And everyone we tested this idea on in the kind of nerdy world was like, that's the coolest exercise. I wish I'd had something. And all the students hated it, universally hated it. They just read the Wikipedia page for Gator on red, or the weirdest responses. We had one about working naked, which was supposed to be about whether you should be getting infinite amounts of money for being a programmer, and someone just did this thing about how you had much better airflow. It would be good for your skin to work naked. And so we really tried to get them into the humor thing, and I think you just have to suffer in the trenches until things become funny by accident. Yeah.
So, and this is just a quick screenshot of what Anaconda Navigator looks like. I don't think we have time for the video. So
why don't you just let it run through, please?
This was going to be
Can you hear that or not?
architecture type of subject. I did not expect code to be part of it. As I'm a person who isn't too great with
There's just some
maths.
feedback.
And there's a lot of maths in it. I felt like, well, it's like it was a bit much.
Probably the weakest part was how we're expected to learn Python. There was a lot of computer troubles and technical issues, especially working in the virtual machine. It was a struggle, I guess even a class in itself, trying to get those things to work.
Have you learned anything from the course?
Aside from Python, which is still, for me, at a beginner-ish level, definitely the whole world of the sort of GitHub people and the world of all these open source programming.
Looking back now, I wish I did try harder.
So there's a bit more of that, but there's more or less saying the same thing. The unresolved questions are, is it possible to go slowly enough? So this is a quick graph that I drew on the bus this morning. The dream thing is that they start at nothing in first years and they come up and get better and better. But there were a bunch of students who essentially didn't get off the bottom. They didn't take off until much later. And even if they're learning at the same rate, which is probably unlikely, they will never get to the same level. So I think there needs to be some kind of big push at the beginning to get people going. And then there's also students who come in with some programming skill. And we haven't really thought about where they're going to go, but often they'll find it a bit easy to start with, or they'll crush it for the first few weeks and then get distracted. So we need to find out how to.
In Ben's ideal, the people who are slow and steady overtake those people who have prerequisite.
The other thing was we used GitHub for all the marking. A lot of that was to push people into learning that they're not the only ones in the world doing this stuff. It worked pretty well. There's a bunch of things where it didn't work so well, but we're working on that.
So the idea is you can just track whoever's forked your repository and then mark everyone who's forked your repo.
Another thing is that there were a bunch of leaky abstractions. So we've got a load of foreign students, and we found things like non-UTF-8 spaces in their code, which would break Python 2 when we were on Python 2. Didn't know that non-UTF-8 spaces were a thing. And yeah, we talked about that. Okay. Let's jump to that. So that's us.
Thank you.
Thank you very much. Hang on, whoa.
No,
Keep that on.
Get close to it.
That is time, and it's now afternoon tea. If there are any questions, maybe grab these folks at afternoon tea or come and attack them here. But I'm going to mug you both first. Thank you both very, very much for awesome talk.